Hi everyone. So in the last video, we were able to write a program that will show you the balance given a public key. Try to delete this part from the previous code and let it only contain the show balance function that is exported from here. The reason for this is if you import this file someplace else, it will basically run all the code that's present here. And we don't want that since it will fiddle with our output of the main program. So just make sure to delete it from here. And now let's try to create a program that will let you transfer tokens from one wallet to the other. So let's create a new folder. Let's call it transfer sol and let's add a new file to it called index.ts. Let's export a function here that's called transfer sol, and the arguments to this will be slightly tricky. So up until this point, we've only had public key as an argument. But the tricky bit here is if you only have someone else's public key, you can't really send Solana from their wallet. You actually need them to sign a transaction, which can only happen if you have their private key. The first argument, that is from, cannot be a public key. It needs to be something called as key pair, which is again something that is exported from the web3.js library. And if you look into it, it basically has a few things, and the important bits are it has a public key and a secret key. The secret key is basically what is used to sign a transaction. So you need both of these for the person who's sending the sol, and the to address of course can still be just a public key. So let's try to write some logic here. First of all, as usual, we'll have to create a connection. So let's do that. Let connection equal to new connection, and we've done this a few times now. Now that is done, we now need to submit a transaction to the Solana blockchain, and this transaction needs to contain an instruction that says I need to transfer X amount of sol from my account to someone else. So maybe let's take that as an input as well, which is the amount of sol that you want to transfer from your account to someone else's. And now let's try to create something called as a new transaction. A transaction in Solana actually can contain multiple instructions. We only want to process one instruction right now, but you could submit a transaction which has multiple instructions in it to the Solana blockchain. The instruction that we want to submit is going to be the transfer instruction. So let's store that in a variable. So as you can see here, I've imported something new called the system program. This basically contains a bunch of helper functions. For example, transfer, assign, create account with seed. These are basically commonly used instructions. For example, transfer is something that a lot of people will need to use. A lot of people also need to create an account given a seed. So the system program has basically implemented the logic for these, and the client side functions for this, for example, system program.transfer, basically interact with those contracts. So let's see what input this guy takes. It has three arguments: the from pub key, the to pub key, and the lamp out. So that's fairly easy to know. The from pub key is going to be from dot public key. So from is no longer a public key, it's a pair, so we need to extract the public key from it. To pub key is simply going to be to, and the third argument was lamp outs, which will be lamp outs per sol into the amount that you want to send. This is just an instruction that's been stored in a variable. We haven't yet submitted this to the blockchain. So let's first add this to the transaction, and then let's submit this to this blockchain by calling send and confirm transaction. As the name suggests, this will send a transaction to the blockchain and will only exit once the transaction confirms. The arguments, the first one is the connection that you want to use, the second one is the transaction, and the third one is something called signers. Since we've only given the public key of the two wallets right now, the wallet that actually needs to send the Solana, or the wallet that will have the Solana debited from their account, they actually need to sign this transaction, because only then can we confirm that someone who owns the secret of that wallet has signed this transaction and has. So if you look at what arguments it expects, the third one is a signer array, because you could have multiple signers in the same transaction, but we just need one right now, which is the from key pair. So let's add that here. There is a red squiggly here because this is not an async function. So let's make it an async function. And I think that should do it. Let's try to log done here, and let's try to call this for two wallets. So we already had one wallet up until this point. Let's first create a new one, and then let's see how you can initialize a key pair from it. You can do that by calling Solana keys in, And if we call this as is, it will overwrite our old wallet, which we don't want. So you can add a new parameter here called --out file, which basically represents the path of the new wallet. So now we have created a new wallet, and this is the secret for it. Let's copy over the secret and see if we can create a key pair from it. The way to do that is you first need to create a uint8 array. The arguments for which will be this array. And you can initialize the key pair by calling the from secret key function on the key pair class. We also need another wallet, the wallet that we need to send it to. That can basically be the wallet that we had initially. So const public key is equal to new public key and the initial wallet address, which was basically this guy right here. So let's rename this to from key pair because this is the wallet that needs to be debited. And then let's rename this to public key because this is where we want to send the Solana. Now the first thing you need to do, of course, is add some Solana to this from key pair. As we saw in the last video, there will be a lot of async code here. So let's create a wrapper around this and add a bunch of async code here. The first one will be, well, you need to first airdrop some Solana to the wallet that's sending it. So let's do that. Let await airdrop from key pair dot public key comma the amount. So let's say we want to just transfer 4 sol for now. And there's an error here that says public key is not assignable to parameter of. And the error here states that it's the thing that we're passing is a public key and it expects a string. So that's why generally you should have this argument as public key. So let's do that. You could also convert this into a string, but that's just an ugly way of doing it. Now that that's done, let's log the current balance. So initial balance of this wallet is of from wallet is, and we can use the get balance function that we exported in the last video. Or was it called something else? It was called show balance. And we still need to pass the same thing, which is the public key of the from wallet. And there's a yellow squiggly here, and that's because this is an async function. To write it more clearly, let's abstract this out into a new variable and let's log it here. So this is the initial balance of the from wallet key, and let's do the same thing for the to wallet key. So this will basically be something like this, and we can log this here. So this first section of the code basically logs the initial balances and also airdrops some Solana to the initial wallet, because if it's empty, it won't be able to send that amount of Solana. Now let's call the function that we have defined above. The function is called transfer sol. It is an async function, so let's await on it. The arguments were the from key pair, which will be this guy, to public key, which will be this guy, and the amount, let's say we only want to transfer 2 sol. So yep, if you wait on it and recheck the balances after that, we should hopefully see a transfer. So let's try that. I hope that was clear enough, that we're basically fetching the balances again for both the wallets and then logging them again. Let's see if we've missed something. I think it looks good. Let's try to run it and see if there's an error. And as you can see, the initial balance is 4 and the initial balance of the other one is 54, and the post balance is 1.999995. That's because it also had to pay some gas fees, which is really small, as you can see. And the post balance of the other wallet is 56. So it basically didn't have to pay anything and it got the whole 2 Sol inside its wallet. So that's pretty much it for this video. You can try fiddling around a little bit more with this. Maybe create a more complicated example. Maybe fiddle with the instructions and the transactions here. What happens if I add an instruction twice to the same transaction? Does it do what it's supposed to? Let's try that out. I mean, I haven't tried that myself. So as you can see, 4 Sol is what got attempted this time, because we basically inside the transfer Sol function added this instruction twice to the same transaction. So as you can see, we only had to submit one transaction, but the transaction contained multiple instructions and each one of them was processed correctly. You'd also try to fiddle a little bit more with this and maybe not airdrop this guy tokens, or even if you do airdrop them, let's make this amount really high. So 200 Sol is not what this key pair will contain. So let's see what happens if we run this. Ideally it should error out. There you go. And it rejected with an error. Let's try something even weirder. So let's make an airdrop of 50 Sol and let's try to transfer 50 Sol. And since the instruction has been added twice, it'll basically try to transfer 50 Sol twice, and that's not what this guy contains. So show the init balance is, it'll be 50 something because it already has some and we've added 50 to it, but it won't be 100. So if we run this instruction twice, it should ideally fail. What do you think will happen? Do you think the first instruction will go through and the second won't, or do you think both of them will get reverted? I mean, think about it. And there is an error, and the balance wasn't really logged here, but let's see what the balance is. So the initial balance was 57.99 and 60. Let's see if it remained the same or if at least 50 Sol were transferred from the first one. So let's comment everything out from here and run this. And as you can see, it has 107 Sol, 50 that were just airdropped to it, and 57 from the transaction before it. It basically means that even if you had 2 instructions and one of them succeeds and the other one fails, the whole thing is reverted. Like even the first 50 won't go into the other wallet. That's pretty much it for this video. In the next video, we'll be doing something more challenging. We'll be creating our own token. So this won't actually be a Solana token. Like the Solana token is very native to Solana. So lampods per Sol and things like these are actually embedded into the Solana blockchain. But you can always define a contract on top of it, which has a bunch of tokens, has a bunch of owners, has a mint from which other people can mint new tokens and do basically everything that a token is supposed to do. That's not really a Solana token, but it basically has a similar pattern. It has a bunch of owners who can transfer tokens from point A to point B. It can have a fixed supply, and it can also be put on the market to be bought and sold for in exchange of Solana, let's say. So let's get into that in the next video.